right, let's go ahead and fire this thing off. So, good morning, good afternoon, good evening, and welcome to the Rise Up podcast. And today we're going to be continuing our conversation around the ISA-95 standard. On previous episodes, we've had Rhize Verleg come in and talk a little bit about parts 2, 3, and 4 of the ISA-95 standard. We even had an Ask Me Anything about ISA-95, and there's still a lot of questions around the standard. How do we use it? What does it all mean? And that's exactly what we're going to cover tonight, both a little bit of how do you apply the standard and also a little bit of behind the scenes of how we actually go about taking a use case and what's our internal processes for applying the ISA-95 standard to the use case, as well as it's a nice little preview for what you're going to see coming up in some of our training that we're going to be providing that's going to be available to people that are interested in learning both the standard and learning about Rhize. Because we are joined here tonight by somebody who is new with Rhize, who's developing our learning management system, going to be putting together what we'll call the syllabus for that content. I'd like to welcome Tom Lindeback. So Tom, go ahead and tell us a little bit about who you are and what brings you to Rhize.
Yeah, thanks, David. I'm definitely very new compared to some of the other guests like Rhize. I've only come across ISA-95 in the last year and a half. I was a teacher before that for 10 years, before swapping to software engineering. And having just gone through the learning process of ISA-95 and having some of those educational skills from my teaching background, I'm pretty keen to apply those skills in teaching ISA-95 to everyone else.
All right, perfect. So you're probably like a lot of people. I get the standard, but it's okay, cool. How do you actually use it? Is that fair to say?
Yeah, definitely. It's so big. So you learn how to apply some bits, but there's still other bits you need to learn to apply, and it just keeps coming.
All right, perfect. So I'm going to go ahead and I'm going to start sharing my screen here so we can actually walk through just a little bit of how we go about doing some of the things we do behind the scenes. So it's really important for us to, whenever we start working with a client, that there's a good, deep knowledge of the ISA-95 standard itself. And this is just going to be a little bit of review, just in case it's been a little bit since you've taken a look at the standard. But it also demonstrates sort of when we start looking at some of the representations that we have on screens that you'll see later. Just gives you an idea of what do these symbols mean? What do these things mean? What are we talking about? So we'll call this just the legend of, as you see arrows moving through, different colors of things, different shapes of objects that you're on the screen. This is what we're going to look at. So if you look over here on the left, this is going to be your very familiar hierarchy model from part 1 of the ISA-95 standard. The generic version of that, of course, is enterprise, site, area, work center, work unit. And then depending on the type of process that you're looking at, whether it's batch, continuous, or discrete, we're not going to call those work centers and work units, something that's unique. So it helps us identify what type of process are we in just due to the virtue of the names of those objects. What we've also done is tied in the equipment module and the control module. Those are going to be how we're going to implement the ISA-88 standard in our process. Not something we're going to focus on tonight, but for people that are curious of, hey, how do you merge these two together? This just gives you a little hint of how the two standards fit together. There's a really great technical report on doing that. And of course, we're also going to have storage zones and storage units. So that's going to be common to all types of process units, whether you're batch, continuous, or discrete. But you'll notice that storage zones are still in that yellow rectangle. But we're going to do a storage unit as a triangle. And then if it has a dotted line around it or a dashed line around it, that's going to mean it's movable storage. It's a storage object, but it's going to be some equipment that we're going to be moving around through that. And then, of course, over here on the right, we're going to have our actual material flows that flow through. So we're really just going to be focusing on material movements through this fictitious factory that we're calling the juice factory. And then, of course, we're also going to have process segments. And we'll get into a little bit more about what a process segment is as we start diving through this. So far, so good, Tom?
Yeah, definitely. Looking forward to, I think, the continuous process stuff in particular.
Sure.
So far, all the implementations I've done have been, batch or discrete.
Yeah, exactly. So as we start taking a look at this diagram, again, just a little bit of background information on the ISA-95. So if you look at the various parts of it, mostly 2, 3, and 4, it can start to become somewhat ominous. And even looking at this diagram at first glance is like, oh my gosh, there's so much complexity here. And yeah, there is some complexity for sure. And that's because we're trying to have a standard where we can capture as many of the most common activities that occur through there, giving a little bit of flexibility in the process. But once we walk through this real fast, and for a little bit of a more of a deep dive on this, you can take a look at some of the previous videos that I mentioned. But we'll notice here, I guess a couple other things I'm going to point out. As the top, you're going to see there's the definition and demand. So you'll see really what's happening in this particular area. And then you also see here on the bottom, you're going to have the level 4. So we're also going to tell you where these types of models, where this type of information exchange is going to exist. Remember, the whole purpose of ISA-95 is to integrate our business systems with our manufacturing systems. So getting into it, the very first thing that you'll see is that's common through this entire diagram is what's known as our resource specifications, or the resource models. So every of these process segments, in the process segment version, there's always going to be these resource specifications. Those are your materials, your equipment, your personnel, and your assets. So every one of these process segments, as they start to evolve throughout the entire both parts 2 and 4 of the ISA-95 standard, you're going to see the evolution of that. But at its core, it's the process segment. That is the smallest unit of work that you can do inside of a factory. It can be something as simple as clean bottles, make juice, something as generic as that, or move material. It means you're going to have some small amount of work or unit of work that's going to occur. And within that unit of work, you're going to have those resource models, the material, the equipment, the assets, and the personnel. So the first thing you do is you want to move from generic to more specific, is now we're going to get into the operations definition model. And this is where we're going to take a process segment or process segments, and we're going to build an operations definition. So as we see a little bit later, we're going to make red juice on mixing tank 1. And that might involve several process segments or operations segments as we build those out. But the operations definition will include all of that information and all those process segments that are part of doing that type of operations definition. So process segments are generic, operations definitions are very specific, but we really haven't done anything yet. We haven't planned any work. It's just, this is the recipe for how we would go about doing whatever this activity is, making juice, packing juice, that type of thing. In order to actually,
yeah,
go ahead, Tom.
Would it be fair to say process segment would be clean a bottle, and then the operations definition would be clean, bottle 3 at cleaning station 1?
Yeah, absolutely. It's perfect. It's exactly what it is. It's taking the template and having an instance of that template. If you're familiar with programming and classes and instances of classes, it's the exact same type of thing. Perfect. And Tom, as we go through this, please feel free to interject as you need. So. Yeah, absolutely. So now we're getting into demand. So over here to the left, we've done some definition of what are the things that are involved in here. What are the activities that are associated with our manufacturing? How do you define what we're doing? Well, now we're going to create some demand. We actually need to do some work. So now we get into the operations schedule model, where we're going to have an operations schedule that's going to have an operations request that's linked back to this operations definition. Make red juice on mixing tank 1. And then we're going to have all the segment requirements. So what are all the process segments that are associated with that? And then we're also going to have some segment parameters. This will make a lot more sense as we get into how we're going to build the model and some what I'm going to call the KPIs, what's there. But again, we're going to have the resource specifications that we're going to not only just make red juice on mixing tank 1, we're actually going to do it on a specific date. And we're going to request all the equipment, assets, personnel, and materials for performing that particular work. Now, you noticed here we've stayed in that level 4. These are all the things that the ERP knows, because it's probably going to make this operations request for us to do something. It might even give us an operations schedule of this is when I'd like you to do it. Really depends on what's involved in your ERP. But sometimes there's going to be activities that occur in your manufacturing plant that the ERP is not going to have visibility of, or it's not going to have any knowledge of, because fundamentally it doesn't really tie back to anything that's going to occur in level 4. Perhaps that's just we're moving some materials. I need to plan that work, but it doesn't really matter to the ERP other than at the beginning and the end of it, just say, hey, it's no longer in tank 1, it's now over in tank 2. I still have the exact same amount of inventory, so that might get reported back. There's a lot of reasons we can do that, and we'll actually get into that. So what we want to do is actually break that down a little bit further into the level 3 area of give ourselves some flexibility to perform some work utilizing those resource models that we're not necessarily going to exchange information between our level 3 and our level 4 system, but we want our other level 3 systems to be aware of this type of stuff is happening. So we've actually created this concept of the work master. And the work master, think of it as if you have the Betty Crocker cookbook, for example, and it's going to tell you how to make a cake. That's going to be that work master. And one of the settings in that recipe is preheat your oven to 375 degrees. Well, you might have a piece of equipment that only goes in 10-degree increments. So we're going to be able to break that down into a work directive. But all that's happening here is that we're just going to define this work master. You still have all the resource specifications that are going to be associated with that, but we're not necessarily going to be tied to that process segment. These are going to be some work masters, and there's going to be some workflows that are associated with that. So that's really just the definition of the things that happen at the, what's part 4 of the standard or level 3. But now we're going to get back in the demand of, remember, we're making the red juice on mixing tank 1. I'm now going to create a job order. I've created this, I'm going to call it an instance of the work directive. There's still some back and forth exactly how those relate internal to us. That's the beauty of the standard, is that there's different ways to apply it. We just need to come to an agreement and alignment on how exactly we're going to use these various models within our own organization. So now, similar to this operation schedule, we're going to have a work schedule. We're going to have a work request. So we're going to do some things. Maybe there's a job order list that's just going to be a task list of all the things that need to happen within that job order. So, as you were talking earlier of, clean a particular bottle at cleaning station 3, those are the types of things that might be associated with that. But this is not going to, the work directive is going to give you the specific recipe that you need to make around making that particular cake on that particular equipment that's there.
Yeah. And that's the business layer doesn't really care exactly how it's made. They just ask that you make it.
Yeah, exactly. So,
is telling you exactly how to make it.
Yeah. So for instance, it could be that I need to make 10,000 units of some particular product. It's 10,000 pounds of juice. I need to make 10,000 left-handed blue widgets. There's something that I need to do, but because I'm going to have some limitations of my equipment, I may only be able to make, say, 2,000, 2,500 at a time. We're going to process it as a job order, 2,500 at a time. We're going to schedule all that same equipment, but it's going to be more in this level 3 because all that the segment response, all the ERP is going to know is that we've scheduled this work. It's going to get broken down. It's going to know the full schedule, but it's not going to know the individual schedule in that level of granularity because it's really not important for the ERP, to know all of that information that's there. So this is just going to be your work schedule. And then finally, staying in that level 3 area, we're now going to get to the result. So we have the definitions. What are the things that we're going to do? We have the demand of, when are we going to do it? What are the things that we're going to have to associate with this? What's all the requests, or, what is the plan is another way to look at the request. Now we're going to get in the response. What actually occurred? We wanted you to make, some red juice on mixing tank 1, but all of a sudden, mixing tank 2 had mixing tank 1 had a maintenance issue. So we ended up actually doing it on mixing tank 2. Well, that's going to come into the response. And so now we can start building all of our KPIs off of what did we actually plan to do and what did we actually do in that particular process. So here at this level 3, we're just going to keep it contained. We're exchanging level 3 to level 3, but then finally we're going to roll all that information back up. We're going to have this work performance is going to now be calculated. We're going to provide that work response, and that's now going to eventually become an operations response. So maybe these 2,500 units of things that we did, that'll eventually get rolled up into the operations response. And by the way, we made 2,500 of these things. You can now account for all that material that we consumed. You can account for all of the material, the finished goods that we produced out of that. And all this information and all these segment responses, remember, we might have multiple segments that are part of this overall operations definition that we have now scheduled. We've made requests, and now we're giving the operations requests that are there. So just a nice quick overview of the ISA-95 parts 2, parts 4. Certainly we could start putting in some parts 3 to show you what that work master is doing and what some of this workflow is, but that's for another time. So this should all be pretty familiar to you so far. Any questions before we move on?
No, that's all looking very familiar. Obviously, I haven't done much with the process segments, but from that point on, it looked very familiar.
Yeah, I think once you get your head wrapped around if you understand the process segment, your resource definitions, the rest sort of falls into place. So again, there's a lot of things going on, and just to be fair, there are additional models. There's a testing model that you might want to use for, okay, I need to test some of the material coming off. What does that look like? So there's some other things that are here, but from a high level view of we're going to be manufacturing stuff, this really gives you a good starting point for what it is we're doing around ISA-95.
Yeah, definitely.
So getting back into our internal process, what we want to do now, of course, is start applying the standard to the use case. So if I've mentioned, we're now modeling this place that's the business, the enterprise. It's called the Juice Factory, and this is their Springfield location. This is their Springfield site. And as we've gone in and worked with this particular client, we're first identifying what are all of the areas that exist inside this. And these are going to be the manufacturing areas where a certain amount of work is done. And like many manufacturing locations, they're always going to have loading docks or where they're doing material receiving. Well, we actually have that at the loading docks area. We now have a work center that is material receiving. And in that material receiving, we actually have labeled this as a work unit. This is loading dock number 1, and there's actually going to be 3 of these. So when you see this little symbol here, that means I've labeled it as loading dock 1, but there's actually loading dock 2 and loading dock 3. And what this means is that we can concurrently unload 3 trucks or receive 3 different materials at the exact same time. So that ability exists within this particular factory. Next area we run into is raw materials. So you'll notice I have some storage zones here. So we have a storage zone of sweeteners, we have a storage zone of colors, and we have some storage zone of flavors. But we also have a work center. And where this work center is where we're going to do some material preparation. And what happens here is that when we're ready to make some juice over in our production area, what we're going to have is an operator who is actually going to fill up some product totes, and they're going to transfer that material from our raw material storage area, from these storage zones that are actually in these, the sugar silo, the 5 color silos, and the 5 flavor silos. And we're going to move those into 30 different product totes. So 10 are for sugar, 10 are for color, 10 are for flavors. So that's what that 30 means here. So that's what's happening in our raw material area. Now we get into our production area. This is where we're actually going to start making the juice. So we have a work center that's called mixing. And in that work center, there is a work unit of mixing tank 1 and mixing tank 2. And what this allows us to do on this particular work center is we can actually do 2 different batches of juice at the exact same time. And we very cleverly call these red juice and blue juice and green juice, purple juice and orange juice. Well, that now allows us and tells us that we can actually run multiple manufacturing orders, job orders on the exact same piece of equipment in this work center. Once we're done making that particular product, we're going to now move those into another storage zone in our bulk juice area. We have a storage zone that's going to be our juice silos. There's 5 of them to go with all of those 5 colored juices that we made. And of course, there's also another work center. And the reason why in this particular factory is because this particular company, they might sell bulk juice out to other companies who want to bottle it themselves. They may we may do some contract manufacturing where we make a specific juice. They don't have the ability to do it, but all they want to do is buy bulk juice, and then they want to bottle it themselves in their own particular factory, and they market it as their particular brand. Not very uncommon. However, Juice Factory, we also package up juice as well. So there's another work center. So similar to this material prep, we're also going to have another material prep work center that's going to be here for our bulk juice. And what we're going to do here is fill up, and it looks like I'm missing a segment here, but there should be a material transfer tank where we can actually move that material around. So that's something that, as we now go through this, looks like that got missed and overlooked in the design. So something we need to make sure that gets corrected in the future. And of course, that now goes over into packaging. We have a work center of line 1. There's actually going to be 4 of these, which is why you see there's a filler 1, capper 1, case packer 1, and palletizer, and all of that information's here. So this is in our package area where the company's going to take bulk juice, and they're actually going to package it up. And then finally, when we're done with it, we go over into the packaged juice area, and that's the storage zone. It's called packaged juice. And you'll notice now that we have another storage unit that is for juice racks, and there are 5 of them. So just seem pretty straightforward of what this factory looks like and what they're doing.
Yeah, definitely. So that missing one would be kind of like a vat that you could move around with juice in it.
Yeah, there should be some more transfer tanks that are sitting there. There's 5 of them that should be sitting here. I would do that live, but I'm sometimes remiss of getting into too much into the weeds on doing that. But just understand there should be another transfer tank here, and there should be, I believe there's 10 of those that should be sitting here as well. But that's exactly
is that something that you could move straight to a loading dock and put into a truck that's going to their factory?
So exactly. So this for the work center, you could also just right from the storage, we haven't modeled that here, but from this particular juice silo, we could also have, use this work center we could also just transfer juice as well. That would be probably another work center, because we're now just taking juice from a silo and putting it into a pump. But for this particular case, we didn't represent that for what it is for this particular application.
Awesome.
Yeah. The scope of this is just for the effort that's going on here of this just internal process. This was something that would come on an iteration, but not a problem, because now all we do is just need to add in that work center, add in the equipment that's associated with it, and all the resource models, and we'd be able to take what we already did and just continue to build out the model to account for that use case.
Yeah, definitely one of the advantages of ISA-95 in that way. You can start small and keep adding on, and it doesn't ruin what you've already made.
Yeah, that was actually one of the questions that came up in the recent Ask Me Anything was, do you have to do the whole thing at once? And the answer is no. Build for your use case and just continue to build it out and continue. And as we like to say, I can solve any problem. Can I scale it? Can I extend it? Well, we can extend it very easily. We just continue to add on the things that you need. Which is why, just real fast, why you notice that there are these. Why we have process segment versions. So we're going to create different versions of all of this, just because we know that things are going to change. So, as we start looking back at what happened in the past, we're going to know, well, that was on a previous version. So we know only this information is available, and we always have access to that. So let's start getting into a little more of the weeds of what we're actually doing now. So now that we have modeled all of their equipment, have an idea of what our other areas are, what all our work centers and work or storage zones are, as well as all the work units and storage units. Now let's build out our process segments. So we're going to go through the exact same process flow. What I've done here on the top, let's call it the generic version. These would be the process segments. We continue to call them process segments, even though they might be part of an operations definition, just because at its core, what it really is able to be traced back to is that fundamental, what is the process segment that is there. So just real fast, and I think I'll go through these in parallel, is that, so here on the top, we're just going to see the generic version of what we're doing. On the bottom, you're going to see a specific instance of, we're going to use the red juice as the example. That's actually what we're going to be making and what we're going to be bottling through the process. So here on this material receiving, we're going to have a process segment that's called receive material. So I can receive sugar, I can receive sweeteners, I can receive, colors, I can receive flavors, all 3 of those at once. But that's going to be our receive material. It's the smallest unit of work I can do. We're going to have a material class. So remember the green line, that's going to be all good product through here. And now we're going to move it into that storage zone, into that storage silo itself. On the specific instance, you're going to see that we're going to have sugar. We're going to have in our storage zone of colors, we're going to have our red color silo. And then of our storage zone of flavors, we're going to have our cherry flavor silo. So we're receiving sugar, receiving color, receiving flavor on these specific instances of the process segment. So going into our raw materials area, this is now we're going to do that materials prep. This is where we're actually going to start filling those totes. So at that work center that's still in the raw materials area, we're going to prepare a material. or specifically, if we're making red juice, we're going to prepare sugar, prepare red color, and prepare red flavor. So you'll notice that this moves into a product tote, which is sugar tote 1, color tote 1, or flavor tote 1. Now, keep in mind, there's 10 of these totes, and it may not be, it may be number 8 for the sugar tote, maybe number 6 for the color tote. It all depends on what's available to us at that particular time and what we're working on and what equipment is available. But for just to make this simple, we're just going to fill it all in flavor tote 1. And then, of course, now you can see that material movement. This is our good product. It's our sugar, our red color, and our cherry flavor. So now we're coming over to our mixing tank. You notice that we have a storage unit. So we're going to have an RO water storage tank that's probably coming from our utilities area. So that's going to cross the boundary of into our production area. And in our mixing tank work center, we're actually going to mix juice. That is the process segment. So purple in this case, this is a consumable. This is just going to be some water that we're going to be consuming for the making of this process. We don't actually track, say, a material lot or sublot of this of water through here. So it's now a consumable. And you'll notice that it's the exact same thing. We're making red juice. We're just going to consume some RO water, and that's going to come into our production area. Once we're done making that, we're going to move it over into our juice silos. So you'll notice that it's just going to go into our bulk juice area or going to our red juice silo when we're done making the particular make red juice on mixing tank 1 is our operations definition. This will be the same. So we're going to have bulk juice areas where we're now going to start transferring the material. So this is that in the previous diagram that I mentioned, we were missing that transfer tank. That's where you're actually going to see that here, where we're now going to prepare, do another material preparation. We're going to transfer some material, and we're now going to exist in a transfer tank. Same thing that's occurring in the bulk juice area. And then, of course, in our packaging area, we're actually going to have a material changeover. So in our packaging line 1, we're actually going to have 2 different process segments. So you remember earlier when I mentioned an operations definition, you might have multiple process segments that are associated with that definition, or I should call them operations segments in this case. This is where I'm going to do that changeover. So I'm getting ready to package red juice, but I might need to change my caps. I might need to change over my labels. That's all going to be done probably concurrently with this material preparation step, but this is the process segment that will occur. I'm still performing work here because this is all part of the work process that needs to happen, but we're just calling it changeover at this point. So that's a very specific unit of work of it's just changeover, that we're just getting ready to do something. And then finally, when we're done with this, we're going to have a material class. This would be the generic version of it. In this case, we're going to have a material definition for red juice. That's finally going to go into our storage zone of packaged juice. And now on the red juice rack, you're going to see the completion of all of this particular work. So what this is doing is it's mapping out the exact process of what are all the areas where work occurs, what are all the process segments that need to be created with that. And what we would also have in this case are what are all the materials, what are all what's all the assets that might be associated with that. If there's, say, a specific on this mixing tank, a mixer impeller, or what are the number of operators that are associated with that. All of those resource models, those will be included in that particular process segment as we really get into the weeds of that. So far so good, Tom?
It's something that you don't have to include the operators to begin with, and then as you expand your implementation, you can put those in.
Yeah, absolutely. Yeah. So we generically refer to them is that we know that there are resource models, there are resource specifications that are associated with everything. We know those are coming in, but this just gives us a nice way we've built the equipment model. We've now built the process segments in. These are the things that need to happen. So once we're done at this point, this is part of that internal process. And we've now done all of the mapping. We understand all of the equipment. Now we have in the particular use case, we need to talk about what type of screens already exist. Can we get a wireframe of what are the types of things that need to occur in there? And in this particular case, keep in mind that this is not meant to be this is not a good UI class. So, look at this and go, wow, that screen's horrible. Yep, you're absolutely right. That wasn't the intent here. It's just to give you an idea of now that I'm going to actually start applying the standard to it, what are some of the ways that I'm going to have operators that are going to be interacting with this particular information? So here we're going to have the operations overview at the top. These are going to be the manufacturing orders that are going to be coming from our ERP. So somewhere along the lines, the juice factory has received an order. We need to make some juice, or we need to package up some juice. So what we're going to have is there's going to be manufacturing orders that are associated with that, how much at the work center where that might need to take place. Now you'll notice here, this work center, it could be generic A. Any one of the mixing tanks, we don't care either way. Just at one of them, you're going to make some juice. Or we can be very specific of, actually, we need you, our request is that you're going to do this on packaging line 1. Here's the manufacturing order that's associated with this. One thing we noted is after we started doing the wireframes, we actually need to call these packaged red juice, because technically this is a different material definition. You'll have red juice, which is going to be bulk, but once we bottle it, it should be denoted as a different material definition. So that should be packed red juice or packaged red juice. There could be a different way that we go about associating that, but we know that this is going to be existing at that packing line 1.
Yeah, even packaging it differently, whether you're doing your own branding or someone else's branding, would be another material.
Yeah, absolutely.
Altogether, and could be a different request.
Yeah, and it would have a different material name. So, these are generically referred to as product codes. Material names can be called anything. Begin date, generally speaking, is when did this order get scheduled, and the end date is this is when you need to have it. So it's more of a demand of, we know that usually takes you from the time we put an order on our factory, usually takes a couple of weeks. So that might be your end date that's associated there. Really just depends on the ERP and what level of granularity they have. I've seen some ERPs, they manage everything. What they send down, it's all ready to go. They want you to do something very specific on a piece of equipment on a particular date. But what we need to do now is get into that finite scheduling, because we know that there's a lot more granularity than sometime between now and in a week from now. So we want to start planning some work that happens on the floor. So this will now give an operator or the scheduler an opportunity to select a manufacturing order, select what equipment's going to run on, what type or what the quantity is. So this may be some of those limitations that might be there of, well, we need to make at least 2,000 in mixing tank 1, but we can't do any more than 5,000 on mixing tank 1, and we need to do 12,000. So I'm going to break up and have a couple of different batches that I run on this particular thing. You'll notice the end date is grayed out, because we're actually going to use some of the information that's in our operations definition that's going to tell us, well, this number, based on one of your process segment parameters that I referenced earlier, you should be able to get an end date out of that. And we're going to dynamically calculate that for you based on the quantity and your begin date. So that's what's going to be there. Certainly have the opportunity to override it. And now you're going to schedule the work. And that's actually going to now allow the operator to put schedule of, this is now what we're going to manufacture on a particular date. We'll also have a material receiving area. So we talk about all the silos. You'll notice that there'll be a red color silo. It'll tell you what's in it, how much is there. It'll give you a lot number that's associated with it. But it does the same type of thing of, we're going to have interactive between, there's going to be a purchase order, something we need to go out and procure material that it's now arrived. We'll be able to look for what is that particular purchase order. Some of the stuff should self-populate, but maybe on the same purchase order, there's multiple product codes that come in on it. So we're going to have multiple products that come in. Where are we going to move this material? Is it going to go in the red color silo, blue color silo? Ideally, this would get restricted based on what you can do there. That's some of that business logic. How much did we actually receive off of that? And of course, what's the lot number? They'll probably be scanning a barcode. Now we're going to receive material. Material preparation is just it's a material transfer. What I've demonstrated here is what's occurring in the prepare material step. So this is occurring where we're going to make some juice. That's what you see here. I can now select the job order that's associated with that. So when we do the material prep, it's not actually work that the ERP is aware of, but we still need to schedule it, because all the ERP, all the level 4 system is interested in, and is us making that 12,000 pounds of red juice. But I need to move some of the material over first. And this is going to be handled by a recipe that's going to come from somewhere it's a little out of scope of what we're doing here, but we know we're going to get 20 of color, 20 of cherry flavor, and 200 of sugar. And we're going to move those into color totes 1. So if you remember earlier in a few steps, this is what we talked about of how we're actually going to start moving some of that material. But we can now begin the operation of actually transferring that red color into that tote, transferring the cherry flavor, into the tote, and then of course transferring the sugar into the tote. One thing I'll call out here is you noticed over here we received red color 1, cherry flavor 1, but when we fill those totes, we have red color 1-1, cherry flavor 1-1, and of course sugar 1-1. And what this is representing is that we're moving from the concept of a lot to a sublot. And when we get into the next screen, you'll start seeing a little more of where that comes in. But what a sublot is that it's all of these sublots, or excuse me, a lot is made up of a sublot. And that's the relationship that we're going to bring into ISA-95. So that's been demonstrated here. And you'll see this material preparation again when we do the material transfer, when we're actually going to go from those bulk silos into the actual packaging of the line. And then, of course, now we're going to get into production. So we're going to select the job order. This is just information of when did we actually start, what's the duration of it, what's the estimated time. But we're going to have some pop-ups here that this is when the totes actually arrive at the production area at this mixing tank 1. We can confirm what's in that particular sugar tote, or perhaps there's multiple totes that are sitting there for multiple orders. We're just going to take, in order, best way to do it is your first in, first out, but it does give you a little bit of flexibility. So there's a pop-up for you to choose what that material is, or what that, what the tote that you're working with is, and those types of things. So there's going to be some dialog boxes that show up, and you'll see that for all the color totes. And then finally, we're going to begin the operation. You'll see some information about what's actually happening in there. So you got a mixer, temperature, level, pressure. It just gives you an example of some of the types of things that are there. So you notice that we still have those exact same sublots of material, but now we're creating a new material. This is our red juice -1. So this is actually this is a sublot, or excuse me, this is a lot of a new material that we've just created in the production area. And then finally moving over into packaging. And as I mentioned earlier, this probably should have a different definition of packed red juice, because we want to distinguish it from the earlier material definition. It's not bulk red juice, it's packed red juice, and it'd be just from a granularity standpoint. So, something that as we start moving through iterations, that's when you realize, we need to get a little more clarity on that. So now we're going to move into the transfer tank, and we have red juice. I got an extra number in there. That's not quite correct. So this is now going to be a sublot. So remember that we had that same lot to sublot relationship. We're going to have that exact same. You know what? I'm sorry. I misspoke here. I'm actually pulling from red juice #1, and now we're coming into the materials. So we come into the packaging area. We've made a red juice 1 on the previous step. Now coming in, we've done that transfer step. Now we're going to choose. We're going to have that same pop-up of what work order am I actually working on for this particular order, and we're going to run the change order. And I should clarify that should also be job order. So even as we go through demos, sometimes we realize that, we didn't get that cleaned up the way that it should have been. So it's always amazing how many errors you catch when you're actually starting to present those types of things. But so now it gives you a sense for what's happening on the equipment. So you got your filler capper, case packer, palletizer, and you get a sense for what's going on there. And then, of course, on the overall line, there's a little bit of information. And finally, you can see that we did when we were building or getting this last screen developed, this is now known as packed red juice 1. So the same relationship of we have a sublot here. We've now created a new material definition. This is now packed red juice, and it's now going to have a particular lot that's through that. So these are the screens that we're going to be working on.
Yeah, I think probably 2 comments from that is you can definitely see the advantage of it being a headless MES / data hub there, where you can implement the front end however you want, and it's very changeable on top of the existing data structure. And I think you also really see the advantage of ISA-95 there with the different containers containing, so you got a process segment that contains, the operations definitions and things like that. You can definitely schedule on a really granular level or on a really high level, and both work.
Yeah, absolutely. Tons of flexibility, but there's a way to go about and applying the use case, regardless of the complexity of how your particular process works or your manufacturing process works. We know there's a way to go about doing it. So, like I said, I noticed there were a couple things in the wireframes that need to be cleaned. These have since been iterated on since they were initially developed. And I'm confident those were caught because I caught them here again. But just gives you a sense for the types of things that we're working on, of what an operator might be interacting with or what somebody might be interacting with in terms of doing some of this work. So I wanted to revisit the ISA 95 just a little bit. So as we start taking a look at how all of these models fit together, this is just more of a restatement of that larger picture we saw earlier. So if you remember, we had our definition, we had our demand, we had our result, we had what occurs at level 4, what occurs at level 3, and then of course back up at level 4. But the reason why I'm showing you that is that as I get into actually mapping ISA 95 to the use case, I didn't want to have all of this information displayed on one screen, but I wanted to give you a sense for, as you watch this particular video, that you can refer back to this screen and you can see how all these models relate together. So here we're going to have that process segment. We're going to have the operation definition. We're going to have those process segment parameters. And now we're going to have the ID of that. So generally when we refer to the model, we use the ID. And that can be something you'll notice in the last screen is that we're going to be looking at theoretical rate. We're going to be looking at the schedule rate. So as I mentioned earlier, when the date for the end date was blacked out, that you couldn't actually put that in there, there's actually going to be a process segment parameter that's going to give you what's our schedule rate, so you know how many pounds per hour we schedule this work. So if I have to make 12,000 pounds of red juice, it's going to know, based on that, making red juice on mixing tank 1, it has a process segment parameter that says this is your scheduling rate. So use that and it'll be calculated. Same thing with equipment. So we talked a little bit about some of the properties of equipment. So these are going to be what's the equipment requirements. So we have process segment requirements. So let's look over here on this operation schedule, the operations request segment requirements. These are the 4 resource. There's material and equipment requirements. Let's break that out a little bit more over here. We're going to have the active version. And on that, or that equipment, we're going to have properties. Now we're going to have, and we use the work unit class properties. So we don't actually have work unit itself. We do all of our properties at the work unit class level. So just something to keep in mind, that isn't something that's enforced by ISA 95. That's how we handle it. But again, on that packaging example, this is where we're going to have all of our counts. We're going to have the state. We're going to have all the things that are necessary for running some of the KPIs. So looking at these 4 models here, this would be how all this information fits together, that if you were to fully look at how we've built the ISA 95 schema into the graph database, this is the relationship of all of that information. And even going back to that earlier, when we first talking about how ISA 95 fits together, you can actually follow any one of those lines and get the information from it. So that's how you can start anywhere and go everywhere and get that information back. But anyway, just going to leave this up here a little bit longer, just so you can see how our operation schedule then gets into the level 3 at the work schedule. We now give you our work performance. What did we actually do, plan versus actual, and finally back up to our operations performance. And you can literally just draw a line all the way across and see exactly how this information relates to from left to right, as well as from top to bottom of where all this stuff comes from. So that's how we traverse the overall graph. So
definitely. The graph word you mentioned there is another great example of, I guess, that manufacturing data hub, meaning that you can just query for as much or as little of the below information as you need at the time. And it can make the queries very quick as well.
Absolutely. But that's why it's been in built this way. And then one thing I don't have in here, I mean, it's sort of hinted at, but there's also the version control as well. So I'm just pulling back active version. There's actually another a label in here, another piece of data we can get that's the versions, which will tell us all the versions that have existed for that. So if we need to get a specific version, then we can also query for that as well if we know something's there. So let's now actually get into what actually happens. So this is really once we have all of the equipment model built, once we understand what all the process segments need to be for a particular application, once we've built in some wireframes just to get a sense for how the operators use this, let's start actually applying where do all these models fit on the screens that I've just looked at above, so we know when we need to exchange that information, this is where it's going to get exchanged. So you can see right across the top, we have all of our manufacturing orders. You're going to have our equipment requirements. You're going to tell us what work center this is going to be done. We're going to have an operations request. So this is going to be the manufacturing order or the work order, depending on how it gets termed inside the organization. We generally like to be in terms of, be very specific on when we call things, that we actually call them by the ISA-95 name, but sometimes we have to do a little bit of dance on that. Here now, your material requirements. So I have a material, it's called material name, product code, material definition. What's the quantity of that? Also, I have an operations schedule. So this is when the level 4 system is saying, this is when you should start it. This is when you should end it. So that's now the operations schedule. When I actually go to pick it, I'm going to get the operations request. I'm going to have equipment requirements, and then I'm also going to have my process segment parameters that it's going to tell me what my equipment rate is. There was another error that I found in here, something that got omitted. I actually need to build in an operation drop down here as well, because on a particular manufacturing order, if you remember that we needed to sometimes transfer some material, I need to be able to schedule that as well. So you would have another drop down here that's going to allow you to choose what operation you're doing there as well. But it's another specific operation request that occurs. Once I actually get it scheduled, this is where I'm actually going to start building up my work schedule. So I'm going to have a scheduled end date, scheduled start date. Work request is likely just going to map right to that manufacturing order. My equipment requirements and my material requirements are going to come right from here. So now I'm creating from the operations request and the operations schedule, I'm now going to create some work.
Yeah, and the other thing, really kind of obvious how easy it becomes to have those high-level process segments, and then you kind of just choose them, choose the equipment, choose what type of work you're doing, and it makes itself from that point. Really nifty.
This is how all the data gets mapped in here, what it is that we're doing. And then, of course, we need to have the relationship of what all the data is doing. So let me zoom in on this just a little bit more so you can see what's happening. So the other aspect that we do is once we understand how to build the model and how we're going to map everything that we're doing to the ISA-95 schema, we need to start working on what are some of those data, the transactions that occur with there. So we're going to have our BPMN. So this is our business process management and notation. We have an engine that runs that. This may be timed. It may be triggered on something that's occurring. There's a lot of flexibility in it, but every so often it's going to query for new manufacturing to the ERP, and it's going to return those. And if there's something that's new, part of the way we build that in is we're going to mutate our operations schedule, and now we're going to populate that. Also, from our UI, we're going to query operations schedules. We're going to return new operations. And when we know that we need to start scheduling something, we're going to query operations requests. We're going to return those requests. And of course, we're going to select the manufacturing order that we're going to do. We're going to populate our equipment drop down, which is we're going to query the equipment requirements, return them, select the equipment. We're going to get the schedule rate. So based on our material, and so this is going to come from the operations definition. Remember, that's that process segment or operations segment in this case. We're going to get that schedule rate parameter that's going to be associated with it. Get enter the quantity, begin date, populate the end date. And you can see now that we're all done, we're going to mutate our work schedule. We've hit the button, and now we're going to schedule it back, and it's going to hit the graph. So that's the exchange of data that needs to occur on that particular screen and how everything gets built. Going to do the exact same thing on material receiving. Now, we may not have an actual schedule, but we know that we're at some point we're going to have a truck that we're going to receive. And this is more something that's done on the fly of when we get ready to receive it. Well, we're going to create that schedule at the exact same time we execute the work, but we still want to maintain fidelity to the standard. But here we're going to create this operation schedule with operations requests, equipment requirements, and material requirements. We know that those things are going to get built or that those are going to be necessary. And we're just going to map those right in here. and it's going to fall right back out. This is just material movement. It's pretty simple. I do want to point out some of the equipment class properties that we might include on there. Is the state, is it clean, is it not clean, or is it in use? We're going to have a material definition, and we're going to have a quantity. So that's something that's specific to the equipment itself. But there's a lot of properties that you can have on this particular, on material or on equipment properties. So similarly, we're going to build in what's the workflow? So we're going to query new purchase orders. We're going to return them. And we're going to mutate an operation schedule requests, equipment requirements, and the material requirements. When we're ready to populate the purchase order dropdown, we're going to access those operations requests. We're going to return them. We're going to select the purchase order. We're going to query material, return it, select it. So it's very much a very similar process. I don't need to walk through all of these, but we're going to enter in the quantity. We're going to enter the lot, likely a scan gun that somebody's going to run in there. And then we're going to receive the material. So now we're going to mutate the performance, operations response, equipment response, material response. We're also going to give it a material lot. And we're also going to trigger the update for the inventory to where now we're going to query the storage unit property. So this is going to trigger a BPMN workflow. We're going to trigger, tell me about that. And now we're going to update inventory back to the ERP so it knows that all occurred.
So just a question here about interacting with the level 2 systems, because I guess some silos could have an automatic, volume reader that tells you how full it is. How would you go about, putting that into this model?
Yeah, so that's what some of your class properties are. So we're going to actually start binding more properties. So maybe there's a level instrument it's associated with that. That might be how we're getting our quantity. There might be an automatic handling system, but how we handle that is that we now have the ability to bind some of these properties into OPC tags or MQTT topics, but that's how we're going to get that information. That's the exchange between our system and the level 2 systems. It's generally through some kind of tag binding.
So then let's say you get an order of 500 liters arriving, and then you fill it up, and the operator says, I put 500 liters in, but then the level 2 system reports 450 liters. How would you kind of deal with that information? What are you showing on that screen there?
Yeah, so if the operator said they received 500, but then the level tank is showing 450, there would likely be some other mechanism for them to correct what's actually there. And that might be something that we're going to trigger down here. There might be an additional workflow that's associated with that. For this particular example, we're assuming that, everything that the tank is unlimited, we can receive as much material as we want, and that we don't necessarily have any kind of mistakes that are made in that particular case. But there's generally mechanisms for how do we account for. We say there was 500, the level says that there's 450. We'll have different ways, because you might have a weigh scale and a level gauge, and they may use one as that what we talk about custody transfer. One's going to be the source of truth for that particular event, but that would all be accounted in here.
Yeah, cool.
So now getting into material preparation, this is when we're going to be doing those material movements. So much like receiving material, now we're actually getting ready to fill up some totes, and you'll start seeing this is starting to look very familiar. I have my equipment requirements. I need to be in a color tote. I have my work request that's going to be used for a job order. I'm going to have my equipment requirements where I'm going to say, what's my material source? Where am I getting it from? As well as my material destination. Where is it coming from? I'm also going to have I have equipment requirements. Then I also have material requirements in terms of the quantity and what material is going to be there. So in these drop downs, you're going to be very limited between what source you can get and what your destination is going to be. And that's all going to be part of these requirements that limit what it is you can do. And then, of course, we're also going to use our material sublots here. So we're going to pull from a lot, and we're now going to create a sublot of this particular material. So these are all the requirements that are coming in. Notice your tote transfer tank properties. I might have a lot number that's associated with it. It could be material definition and a quantity. Lots of properties that are going to be associated. Again, those are equipment properties that are associated with that. And then, of course, we have our schedule time of this is what the request was. We're also now going to get our work performance of this should have taken me 20 minutes. What's my actuals on here? So now I'm going to get work performance, equipment actual, and I'm going to get the work responses, material actual. And then, of course, we're now going to get all the material sublots that are associated with that. So this is now for that next screen of now we're preparing it. And this will be true whether we're doing the totes or we're doing the transfer tanks. It's going to be the exact same type of work that goes there. And you can see this is mostly going to be all between our level or between our UI system and just going and actually interrogating the graph. I'm going to get work requests. I'm going to query equipment requirements. I'm going to get material definition, quantity, lot information. I'm going to enter the quant lottery details. I'm going to dispatch the work. We're going to hit begin operation. So we're going to say, okay, I just began the operation. So now we're going to start reporting back of when did this actually happen. And then finally, we're going to complete the work. And now we're going to say, this is, we started it. This is, we ended it. And there are all the mutations that are associated with that. So this is all just going to recur between our UI system and the graph itself. So pretty simple. This is where it starts to get a little more challenging because there's a lot that's going to be going on this particular screen. But
there's a lot more arrows on this one.
A lot more arrows on here. So let's see if we can't digest it so it doesn't look like oh my gosh. And I will say if you are listening to our podcast, this is going to be one of those that you'll really want to come back and take a look at the YouTube video for what we're actually looking at in some of the screens. So I should have started off the very beginning. This is probably going to be better as a YouTube rather than a proper podcast. So same type of thing. You're going to start seeing the theme of, okay, this is all starting to sink in. I have my equipment requirements. Where am I actually going to be performing this work? I have my work requests. What's the job order that I'm going to be doing? I have material requirements that are going to be what's going to be in my sugar in. I'm going to have my equipment requirements. I'm going to have to be on my sugar tote. I'm going to have what are my sublots. This is something that I might actually have to pick of what sublot has the request. There's a lot of flexibility in there. I may be able to choose from any number of sublots there. Typically, first in, first out is going to be the mechanism that's there. I'm going to have the same thing for the material that I'm producing. So you'll see this is just a restatement of I have a particular material requirement. So a material definition and a quantity. I have certain equipment. You're going to have to go into the red juice silo. And then, of course, now we're going to have some material lots that are going to be created there as well. So you can see this is all the material that's consumed. This is all the material that's produced and all the requirements for that. We're also going to have now what was the actual equipment that it was done on. We're going to have the work performance, which is going to map the schedule that's there of when did we actually begin, when did we actually end. All the work responses, material actual, equipment actual, material sublots for the consumed material, as well as that restatement of material actual, equipment actual, material lots for the produced material. And if you notice, because we've actually consumed raw material and we've made a sellable item, we need to also correlate this information with our ERP so it can account for the proper level 4 or for the inventory. So all of these are just mapped right over to the operations performance. We've actually produced those 12,000 pounds of juice that the system was asking for us to do, that the ERP had asked us to do as part of our operations requests. So
yeah, you can see
makes a ton of sense. It's like, oh yeah, it's complicated, yeah. but you can segment it out, chunk it out, and now it all like, oh okay, that's pretty easy.
Yeah, definitely. I think there you've got the blue writing with the 55 RPM and the green writing with the 54.5 RPM.
Mm-hmm.
So one of those would be on the requirement and the other one would go onto the actual for that equipment.
So what you're seeing here is that this is more of a control, that this is my set point. This is what the recipe is telling me to do. It could be part of my, it might be part of my SOP, or it's, there's the recipe that's associated with that. That's all part of the work master. Fantastic question, but this is just saying this is where it actually is right now. But probably not something that would necessarily make its way up in terms of an equipment requirement. But since you ask, if say that I'm supposed to be running at 55 RPM, but I'm now actually put in 60 RPM, I might get what's known as a variance. And so you would actually have that as part of your equipment actual, but there's a little more that's involved in that. But it becomes, if there's a variance, is the operator allowed to do that, or does there need to be some kind of override? But chances are that's going to go in your variance report of, it's supposed to be 55. I don't map that here, but what you would actually have that is that would be part of your actual in there. But this is just telling you this is the actual process variable, the PV of what the equipment's actually doing right now.
Yeah, cool.
Yeah, this is more of a level 2 type. It's an HMI function. Your blue is your set point. Your green is your process variable, process value, what's actually happening at it. It's actually spinning at 54.5 right now.
Definitely some information we can be storing in the data hub though as a time series.
Absolutely.
And,
sure could.
Yeah, querying that later to see how close the operators got.
Yeah. Now, as this gets built out and we do more advanced classes, those are the types of things that we're going to start including in there. Of there is part of our work master. It's supposed to be at 55. What did you actually run that as, and how do we handle those particular use cases and what occurs there? But much like this diagram had a lot more displayed on it, you're going to see that there's a lot more information that's getting exchanged, but it's going to be very much repetitious in terms of what it is that we're doing. We're going to query work requests. We're going to return them. We're going to get materials. We're now going to populate the pop-ups in terms of what's actually going to occur. So we're going to select all the things that are there. We're going to begin the operation. What I didn't do is I did not, in this complete work, that actually I didn't restate everything to make it just a little bit more compact. But you can see that you'd actually would be mutating all these operations performance up in this phase as well, because I've actually started production. And that'd be information that would be, I had a planned start. I now have an actual start, both for the work request as well as the operations request. So that information would be there. But a lot of this information exchange is just telling you, what did you actually do? Here's all the work responses that are associated with that. Here's the equipment actual, material actual. Here are the material lots. We're going to mutate the sublots. And then, of course, we're going to update the ERP as well, just because we've now produced material. So now we need to update the manufacturing order to let them know that maybe not 12,000, but we did 6,000 or something amount. But there's going to be some inventory moves. There's going to be some accounting that needs to take place there. But that becomes the how we handle that in there. So, and then finally on the packaging piece, also a little bit more of a spaghetti diagram, but it's going to pretty much do the exact same thing we just saw above. Remember, we're going to have those transfer tanks that are going to be included in here, but it's going to get mapped identically to how we did that before. It's just a material movement. And finally, we're going to have in that transfer tank, we're going to have our juice in. There's going to be a pop-up that's going to give us all the material requirements, equipment requirements, and sublots for the things that we consumed. We're going to have material requirements, equipment requirements, and material lots for the material that we produce. There's a pop-up that's associated with that on both sides. And of course, just like the example above, we're going to get some information from our level 2 system as far as what's actually happening in there and some of our counts. When we're done with that, we're going to have the equipment actual. Where did we actually do it? So it's supposed to occur on packaging line 1. Well, we actually did it on equipment line 1. And you're going to get the work performance, work responses, material equipment, sublots for the consumed, the actual material equipment and material lots for the produced. And we're going to map it right up to the level 4 system. I know that's going to be a big shock, but like I said, this is exactly what we did above. One of the things we talked about when I was breaking out the models, we've spent a little bit of time talking about the process segments, but what you're likely going to have down here. So really why we're trying to do this, and these are the questions that we get asked a lot of, how do I start doing OEE? How do I start doing genealogy or track and trace? How do I do SPC? These are all really at its basic level, it's plan versus actual. Those are the types of things or questions that we're trying to answer with all of those. So what you're going to have on your equipment classes is that on this work unit class properties, we're going to have that state, we're going to have the in-feed. So these are going to be all the counters that are coming in and out. We're going to have any kind of, so this is your in-feed counter, this is your out-feed counter. How much material did we start? How much good product came out? How much was a bad product that was produced? What's the work order? that we're working on, or a manufacturing order. A lot of different ways we can call that, but these are going to be some of the equipment properties that we associate with above, so we can start calculating. In this case, we're going to need these values, and we're also going to need your theoretical rate. So we talked earlier about that schedule rate. Well, what the theoretical rate is that if we wanted to calculate OEE off this particular packaging line, we know that we're going to schedule for, say, it's going to be 60 bottles a minute, 60 pounds per minute. But the theoretical rate of, we know that this equipment, we could probably run 72 bottles per minute across this particular. So now we want to take a look at, okay, so what did we actually do? How many bottles did we actually produce? If the equipment's capable of doing this theoretical rate of 72, how many did we actually do? And we can get that through the material sublots, or excuse me, the material actuals that we're getting off here. So this is now how we start taking this information that we've just mapped in and start doing some very basic use cases. Same thing with his material lots and sublots. We can actually do a full genealogy with the information we've now just collected here, because from the time that we received the material, the raw material coming in, to the time that we actually produced finished packaged product, we know the lots and sublots that are associated back and forward with all that information.
Yeah, that view that you had just before the screens, where you could see all these models and how they relate, definitely show how you could trace the genealogy of the material up.
Yeah, that's exactly what we're doing, because we are now able to go back through that. It is it's part of this other class, and those relationships are defined as part of the overall ISA-95 standard.
Yeah, with this juice factory as well, once you've been running it a little while and you happy to start implementing some more features, you can start getting the capability model in there as well.
You can do the capability model.
Accurate OEE things as well once you've reached that kind of maturity at your plant.
You just continue to advance what it is that you've already done. You don't have to refactor. And that's, what you just said, really that's something that differentiates the Rhize manufacturing data hub. Is most commercial off the shelf MES, you're buying a specific function. Now that's not bad. We're not here to say, one's good, one's bad. It's just understand that there's a different way of approaching it, because look, I just need simple OEE. I'm just going to buy a simple out of the box OEE tool. There's a lot of great ones out there, but if you're going to scale and extend, starting with something that gives you a little more flexibility in those types of things. We're not opinionated on how you do it. We just continue to advance what's already there. So really, it's just understanding what are you able to support, and what's the future of that. That's not to say you couldn't scale or extend with other things, but something to keep in mind. This is where we're unique. Is we just build the model. How you consume it is up to you.
Yeah, and if you get a new bit of business software that lets you then start scheduling the lines and things like that, then we're ready to handle it in the data hub.
Yeah, absolutely. Just real fast, finishing everything off here. This will look almost identical to above. We're just going to get the work requests. We're going to get the material requirements. We're going to get all the materials and everything that's, these are some of the requirements that are associated of, where we're limited to getting some of that information. So we're going to confirm quantity and sublots. The operator does have the ability to override that. It just depending on what that particular need is. We're going to dispatch the work. We're going to begin changeover. This is just going to mutate back to let you know this is when we began this particular changeover. We're going to also mutate the work performance once we are ended changeover, we're ready to actually go into production. We're going to do the same thing here. And then finally, we're going to complete the work. As I mentioned above, all of this operations performance, that's going to get done up here, but it became to be a large model. So I've only indicated it here, but those same types of things would occur in this dispatch work statement as well. And then finally, we're going to update the ERP, and we're going to query the operations performance. And now we're going to update the manufacturing order to let them know, or let the ERP system know, we can now account for material that was consumed, material that was produced, and all of the other information that needs to be a part of that particular data payload. So As you can see, we've been through a whole lot of information here, but really what we set off to do is try to explain of how do you actually apply the standard to a simple manufacturing use case. And you see, once you get a little, once there's a little bit of an understanding, once you get the hang of it, it's really not that challenging. Now, I don't want to say that there aren't challenges, because yes, again, this is a very basic use case, but once you understand how all this information starts getting put together, this is what you're going to get into. And you notice that, yeah, we went through a lot of screens here. There's a lot of information that just got put out, but this is the process, and we just followed all the way from top to bottom. Was here's the legend. Just keep in mind this is where it all goes. Build out your equipment model, process segments. You get some wireframes of screens. Just understand this is how all the data fits together, and just start modeling it out. What's the data transactions that need to occur, and here's how you go about getting some of those KPIs. So
yeah, I think definitely highlights. It's a simple use case, but you can get such rich KPI information straight out of it.
Yeah, absolutely.
By using that ISA model.
Yeah, so that's pretty much in it. So I know we started off the idea of, hey, how do you apply this? That's what we demonstrated. But any last questions, comments, thoughts that you had about what we just took a look at, Tom?
Yeah, I think it really demonstrates the flexibility of the system of ISA-95 and also the manufacturing data hub. I think,
very true.
Yeah, you can definitely see as you walk through it, your brain's ticking over with all the opportunities to extend it, and how you could, get more information out of it later down the line when your business needs that.
Mm-hmm.
And I think it really highlights just how easy it would be to keep iterating and developing and make it, a really complete system.
Yeah, it's kind of like learning how to ride a bicycle. Once you get the hang of it, it's like going out, and then you'll be ready for the motorcycle, right? Just like
yeah,
it's whatever.
Yeah, if your parents let you. Yeah.
Right. Yeah. All right. Cool. Well, Tom, thank you so much for spending some time with me today, and thank you to all the listeners for joining us on this episode of the Rise Up podcast. Look forward to you in future episodes. If there's content that you'd like to see, please reach out. Let us know of how can we go about and help you solve some of your manufacturing challenges. But until then, everybody, enjoy the rest of your day, the rest of your evening, and look forward to talking to you soon.
Thanks, Dan.